challenging is because you can make choices, and this isn't necessarily a cookie cutter type of thing. You do this, this, and this, and this. You kind of need to make a choice. Now, I, in looking at this, made the choice, I'm going to make this positive and move it over and not deal with this negative. You didn't, that's okay, but then you had to deal with the negative. And I like to avoid negatives like the plague. I make mistakes when there are negatives. So to me, it was like, all right, just move it over. And then I have a binomial and a monomial, and when I square them, and some of you are still not squaring these correctly, okay, what is the x plus 8 squared going to be?
X plus 8.
X plus 8. So I'm done with that side, but this is a binomial. It's 2 plus this number. And just like last night's homework, where you have to factor these out, you really need to multiply across. Yes?
I gotta think about it, man. Please put it back.
Yes. Okay? So I multiply them out. I mean, I try not to take shortcuts. It's really very easy to make mistakes. I make them all the time. You see that I make mistakes. So you have to be really kind of particular and take your time, and within reason, of course. So 2 times 2 is 4, and then I just multiplied it out. 2 times 2 is 4. 2 times this is 2 rad x plus 4. And then I have 2 times rad x plus, minus 4. And then rad x minus 4 times x minus 4 is it without the radical. Okay? And then what do I need to do? I combine like terms. I moved my x over, and I am left with 4 rad x equals an 8. What do I need to do now? I need to get rid of that radical again. That's your goal. Square your radical each time. And when I square that, which is this, I end up with 16. X minus 4 is equal to 64. And I'm adding, if I add 64 to both sides, I end up with 16x is equal to 128. For those of you who made errors, are you able to see your mistakes or where you've gone it wrong? I'm hoping, because that's what I'm asking you to do tonight, is to redo those problems. Okay? Pardon me? Yeah, I'll get that. Okay, so far so good. I mean, you're seeing where you're making errors. I'm hoping for the most part they're careless mistakes and that you know what you're doing, right? You just kind of get lost. Okay, so in this last one, I checked to see whether or not, is this a quadratic? What was this multiplied by? By 2? 2/3. Okay, so I knew that 2/3 times this would be 2, 2/3 times this would give me a 1. I can use my quadratic, and this is plug and chug. Ailey, the formula is b squared. I know, you need to remember. You need to know this like you know your own hands. If we had a lineup, I took pictures of your hands, and we lined them up. Do you think you would be able to pick your own?
Oh, no. Probably not.
That's bad. You should be able to pick out your own hands. It's like, no, those are definitely not my hands.
Right now.
Okay, so I want to finish up. Hold on. This is the last problem because I want the rest of the time to go over your homework. So I know that I am plugging in, but this is x to the 2/3, and I'm writing that in there so I don't forget. It is x to the 2/3. And this was just a matter of plug and chug. Some of you don't know how to multiply, even though you have calculators in front of you. So I'm just plugging in, and 16 plus 180, I believe, was 196, right, Emily? Yeah, I think you didn't add correctly. I mean,
I did it right.
You did that one right? Okay, so it's 4 plus or minus Here it is. This is where somebody made a mistake. So 4 plus 14 is 18. Somebody else gave me 16 or 15 or something. Right? So 4 plus 14 is 18. Divided by 2 is 9. And so I know that x to the 2/3 is equal to 9. But do I want x to the 2/3? No. So I know that to get this to equal 1, I am going to do what? I'm going to multiply it by the reciprocal, which is 3/2, and then I know I have to multiply the other side by 3/2. Didn't know what to do there, so I rewrote it as a radical, and does that make sense? The square root of 9 is 3, but it would be 3 what? Cubed, which is 27. Okay, so that took a little bit more. Okay, so I gave you credit, I gave you as much credit as I could. If you missed this last step, I gave you partial credit.
How did you get 5?
Yeah.
I ended up with -5.
Yeah, so did I.
Let me see, it would have been a -5, it was an extraneous
Yeah.
root, it didn't work.
Okay.
Yeah.
So like if you just, because I usually check these on the graph first or second. So if you plug it into the graph and you're like, well, it's nowhere near whatever I got, like
Yeah.
11. Can you just use, you have to actually check it, or can you just say it was extraneous on the graph?
Well, you could say it was extraneous, if you have an idea that it is, you just need to be aware that they exist,
Yeah.
right? Okay, all right, so I will give you forms in a second that if you want to make, I would like everybody to make corrections, not if you would like. I'm asking that you do that.
Do what?
Well, maybe tomorrow. We're gonna see how much we get done today. Okay, so let's take out your homework and we'll continue with there. Oh, I need yours. How'd you do? Yeah, well, it's easy to do that when you have it in front of you. Pardon me?
Well, yes, but
Sorry. Okay.
to make it like a binomial.
All right, yes.
No, it doesn't work as a binomial.
Pardon me?
That says yes. It has to be 3 negatives. Because otherwise, look, if you try to do this, if you use
I'm not
x
sure
plus
if
2
we'll
and
try
x
it
plus 2
tomorrow.
as a
Thank you.
binomial.
Okay,
to end up with
so
that,
what I'd like to
you
do
end up
is
with
go
x
over
plus
these
4.
quickly.
You just flip the scoring.
Yesterday, we talked about, we have rational expressions. And
3 negatives.
I'm looking to see how I can cancel, and in order to cancel, I am going to factor. And in my geometry class today, we are doing surface area, and we're coming up with some unwieldy numbers. I think it was, 4 pi over 3 times 729 over 1. And you just need to remember something. If I had said to you, I had 729 over 3, do you think I might try to simplify that?
Yeah.
I would say, well, 3 goes into 7 twice with 1 left over, 3 goes into 12 4 times, 3 goes into 9 3 times. Well, that's a much friendlier number than this number. What you need to remember about canceling out when we have fractions is I know that the order that I multiply is commutative. I can change the order. So if I had 2 21sts over 3 14ths, that's really the same. I could put this 3 here, just put it up front, and then I'd have 21 over 14, and it's like, wow, that's a snap. And I could multiply. But mathematicians are fundamentally lazy. I mean, why do we need to write 1? It's obvious it's 1, right? I don't need to tell you that it's 1x to the first because it's obvious. Well, the same thing happens when I am canceling. I could rewrite this and put this 729 over the 3 and the 4 over there, but why bother? I can just cross. As long as one is in the numerator, one is in the denominator, that works. Okay, so is everybody okay with that idea that we can, as long as something's in the numerator and it's multiplication, not addition, I can cancel anywhere I want, numerator, denominator. Okay, so right here, we're factoring away. I recognize I could do this two ways. Is this a perfect square? Is this a difference of perfect squares? Okay, perfect. So I could write it as x squared minus 4, x squared plus 4, but remember that thing that was going to jump out and bite you? The difference of perfect squares, is there now a difference of perfect squares embedded in there? Yeah, so you need to rewrite that again. We are trying to find all the factors. So I'll come back to this top one in a second. Okay, in the bottom one. Now, I was talking to Mrs. McNichol about this, and you know what she told her class, and I shared it, I think, with Kaylee. Mrs. McNichol said, if you can't factor, you might as well realize you're going to fail this chapter. And she's absolutely right. If you can't factor these guys, you're sunk. Because the expectation is that you can. Now I showed you, Brad showed me his sheet of paper, that worksheet that I gave you in February. If you're really desperate, go back to the blog. I found my lessons on factoring. It's in February. Revisit it. Take a refresher course. Learn how to factor. But you need to have this on your fingertips. It's kind of like knowing your multiplication facts. Okay? So in this case, I know that 3 times 4 is 12. I found the factors of 12 that when combined will give me an 8. And I did the work out. You know, again, I'm a visual person. I figured out what are the factors of 12. And I knew that I could have a negative 6x and a negative 2x would give me a negative 8x. Everybody good with that? Ring a bell? Okay, and so I have my factors. So did I do a box? No, I didn't do a box here. Okay, so I factored it out. I knew that I was going, I don't know why I didn't do a box here, but I did. Oh, I know what I did. I did the grouping method for those of you who do it the grouping method. So the grouping method allows me to rename the middle term, and then I grouped my 6x, my first 2 terms, and then my second 2 terms. I found a common factor, 3x, that was x minus 2. I found a common factor of a negative 2, and then since 3x was being multiplied by x minus 2, and negative 2 was multiplied by x minus 2, they're the same, each multiplying by x minus 2, I just rewrote it as 3x minus 2 times x minus 2. Okay, so I have my factors. I'm going to go back to my top. Remember I told you, let me see, I had the difference of perfect squares, so I need to rename that as x minus 2, x plus 2. And now I am going to do as much canceling as I can. And bang, bang. It appears that that's all I can do. And I believe that's my final answer. And I'm leaving it factored.
I got tripped up on thinking that the x squared plus 4 could be factored down.
Yeah.
Not the difference of perfect squares. That's why why do you think I keep telling you its name? It has a name. And so you need to recognize it because it is special. It's a special polynomial. Okay? Laura, you had a question?
Yeah, that was my
Same question. All right. Let's look at E.
Yeah.
All right. Anybody? Well, do you want me to do E? Do you have a question on E or F? Anything in particular? E. All right. The answer for E was AB squared over 6.
Negative?
Is there a negative?
Yeah.
I can't see right. Yes, there is a negative. Sorry. All right, and let me just show you. This again, I just did a bunch, look at this, 3 and 9, 1 and 3. How about a squared and a? I'm gonna have what? A to the first. B and b squared.
This one you
2
have to
and
factor?
4. What?
This one you don't have to factor.
No, this one was just multiplying exponents. But I could still simplify. Okay? I'm moving along. Sorry, we're running out of time, and I want to just show you F. That was